Bismillahirrahmanirrahim. Today we will start our ninth lecture of digital electronics. Our ninth topic is subtraction. In this we will study half subtractor and full subtractor. Half subtraction and we will do the full subtraction. Okay, first of all we will start from half subtraction. In this we have maximum, we have 2 bits, okay, and the possible combination we can have is 2 raised to power n is equal to 4. These are our total possible combinations. So basically we can make its diagram as the first input A, the second input B, the half subtraction as we made for the adder, the same is for subtraction. So borrow and difference. Okay, in this we have 2 inputs A and B and the 2 outputs borrow and difference. So to make it stable, the inputs A, B and the outputs borrow and difference. The inputs are 0, 0, 0, 1, 1, 0 and 1, 1. Okay, when we will minus 0 from 0, we will have the 0 borrow and 0 difference. When we minus 0 minus 1, we will have to take the 1 borrow and the difference will be 1. When we will minus 1 minus 0, the borrow is 0 but the difference is 1. And for 1 minus 1, we have 0 borrow and 0 difference. Now we have to make the K map for it. We can see for the difference, this is our gate, our logic gate XOR. That whenever we have the different inputs, our output will be 1 and for the same inputs, output will be 0. This is the XOR gate. So for this, we will make our circuit diagram for the XOR. That will be like A and B. We will make our XOR gate symbol. This is the symbol of the XOR gate. We have studied it before. And this is the output A XOR B, and we can say the difference. This is the circuit diagram for the difference. Now we will study the borrow. For this we have to first make the K map, and it will be like A and B. So 0 and 1, 0 and 1. As we have the 4 possible combinations, it means 4 boxes we have. So we will put the numbers in it according to our this one column, the borrow column. On 0, 0 we have 0. On 0, 1 we have when the A is 1 and B is 0. When A is 1 and B is 0, it is 0. On 0 and 1, it's 1 and again 0. So for this we have the answer A bar because it's 0 and the B because it's 1. A bar B. And now according to this we will draw our circuit diagram. To just get the logic expression, we draw the K map. And for the difference, as we can see, this is the XOR gate A XOR B, so there is no need to draw the K map for it. So now to draw A bar B, we have A We will take a bar from it. Our NOT gate, it will give us a bar. We have B. This is our B. This is a bar. And then we will have an AND gate. That is A bar B. This is our borrow. Now we will do the full subtraction. Okay, in full subtraction, we will have the 3 bits. So the possible combinations are 8. And we will subtract it till 3 bits. 8 are our possible combinations. So as we have 3 inputs, so A, B and C. This is our full subtraction. And the output we will have is borrow and the difference, as the same for the half subtraction and the difference. Now we will make the table for it. A, B, C, borrow and difference. Zero, 0, 0, 0, 4, 0 and then 4, 1. Then we will have 0, 0, 0, 1, 1, 0, 1, 1. And then we will repeat it again for 1, 1. 0, 0, 0, 1, 1, 0, 1, 1. Now as we minus 0, so it will be 0 borrow, 0 difference. When we minus 0 and then 0 minus 1, we will have 1 borrow and 1 difference. And for 0 minus 1, 1 minus 0, again we will have 1 borrow and 1 difference. 0 minus 1, we will have to take 1 borrow and 1 minus 0, the difference is 1. So 0 minus 1, 1 borrow, 1 minus 1, 0 difference. And again 0, 1. Okay, now for 1 minus 0 and then we have 1, it will give us 0 and 0. For 1 minus 1 and then 0, we will have 0, 0. And for 1 minus 1 we have 1 and 1. Now we will make the K map for it, for the full subtraction. First we will draw for borrow and then for difference. Then for the borrow we have A, B and C. 0, 0, 0, 1, 1, 1, 1, 0 with 0 and 1. We will fill this K map with the help of the above table and you will get the answers 0, 1, 0, 0. Then we have 1, 1, 1 and 0. Now we will make the groups for it as we did it before. This is the group 1 and then the group 2 and we will take the group 3. Our group 2 and group 3 are overlapping. So we have group 1 plus group 2 plus group 3. It says A bar B plus BC plus A bar C. The answer is A bar B plus we will take the C common from it and it will give us B plus A bar. Now we will make the diagram for it. Our circuit diagram, it says this is A. We have to take the A bar. So this is A bar after the NOT gate. A bar and then we have B. A bar and B are connected by AND gate. So this is A bar B. And now we have BC. This is our B. We'll draw the C, the AND gate, and this is B and C. Then we have A bar with C connected by AND gate A bar C. As we have connected all of them by the AND gate, but we can see that there's also the OR gate is present. Okay, this is not XOR, but I want to say that there is the OR gate is present. Now we have to combine all of these by the XOR gate like this. We have A bar B plus B C. And now same for the A bar C, we will take this in as input and A bar C, and we will combine them with OR gate. So this will be our final answer, which will says A bar B plus BC plus A bar C. Now we will do for the difference. So our K map for the difference is, we have A, B and C. Zero, 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 one, 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 zero, and 0 and 1. Okay, so now for difference we will fill this according to our table. You can see the table to fill it. 1, 0 and 1, 0. As we did it before, this is our checkerboard pattern, and what the checkerboard pattern says, it says that we have the XOR gate. A XOR B, XOR C. When we have 0, 1, 0, 1, then 1, 0, 1, 0, as the pattern is going on, it is checkerboard pattern. Okay. So now we will draw the XOR gate with A, B and C. It is like A, B, first of all they are connected like this. This is A XOR B. Now we will add the C with A XOR B, C, and it will become A XOR B XOR C. This is our difference, our circuit diagram for the difference. I hope this topic is clear to you. We did the subtraction, the half subtraction and the full subtraction, the K maps and the borrow and difference. And now we will do one question, that which kind of the question we can get for the K map or with the half subtraction or the full subtraction. Let's take an example. So this is the kind of question we can get. We have A bar, B bar, C, which means that our A is equal to 1 and A bar is equal to 0. B is 1 and B bar is equal to 0. C is 1 and C bar is equal to 0. And for our easiness, we will write it as A bar is 0, B bar 0, C is 1, 1, 0, 0, 1, 1, 1, 1, 1, 0. Why we are writing these values? It will help us in our K map. So we have A, B, C. 0, 0, 0, 1, 1, 1, 1, 0, then 0 and 1. We will fill these blocks according to the given question. 0, 0, 1. It means on A, B we have 0 and on C we have 1. 0, 0 and on C we have 1. Here we have 1. On 1, 0, 0. 1, 0, 0. Here we have 1. And on the 1, 1, 1. This is 1 and 1, 1, 0. This is 1. The other values are 0. This is how we fill our K map. And now we will have to make the groups. This is our group 1. This will be our group 2. And the group 3 will overlap with group 2. Now we will write them as the group 1 values, which is a bar, b bar, c plus a, c bar plus a, b. A bar, b bar, c plus a, we will take the a common from these two values, and we have c bar plus b. Now we will make the circuit diagram for it. This is the K map, and now we will draw the circuit diagram. Okay, so we have A. First we are drawing the A bar, B bar, C. We will add the NOT gate. It will be A bar. Then we will draw the B bar, and they are connected by the AND gate. A bar, B bar, and we have C with it also. So this C. A bar, B bar, C, they are connected with the AND gate. Now we will draw the A into C bar plus B bar. For first we have to draw the C bar. It will be our C bar, and then we have to take the B, not the B bar. We have to take B. They are connected with the N. No, there's the plus sign. They are connected with the OR gate. This is our OR gate, C bar plus B. And then C bar plus B and A. They are connected with the AND gate. So this is our circuit diagram for the given question. This is A into C bar plus B. Okay. This was our topic of the subtraction, and I did one example for you. So in our next lecture we will study the decoders and the encoders.